friends of chemistry. I'm recording a video for On Your Own 11.5, which is found on page 367. 11.5 says, one way to purify a mixture of two metals is to add to the mixture something that reacts with only one of the metals and turns it into an aqueous compound. The mixture can then be filtered, isolating the other metal. A mixture of magnesium and aluminum was treated in such a way in order to isolate the magnesium. Sodium hydroxide, which reacts only with aluminum, was added in the chemical equation you see on page 367. The aluminum, the 2Al solid, was converted to an aqueous salt, the 2NaAlOH4. And the magnesium stayed as a solid. The magnesium is not even recorded in the chemical equation because it doesn't do anything, it doesn't react. The solution was then filtered, isolating the pure magnesium. Now, if a mixture of these two metals contained 1.2 kilograms of aluminum, how many liters of a 6.5 molarity NaOH solution would be needed to make sure that all aluminum was taken out of the mixture? Okay, so this is just another stoichiometry problem. Okay, so we just have to use what we know to find out what we don't know. Okay, so first of all, we're going to figure out the relationship between the aluminum and the sodium hydroxide, the NaOH. In the chemical equation, we see that for every 2 moles of aluminum, we need 2 moles of sodium hydroxide to completely have a complete reaction, okay? So that tells us the relationship is 2 to 2, or to simplify it, 1 to 1, right? For every 1 mole, we're going to need 1 mole of that. For every 900 moles, we're going to need 900 of that. For every 0.0097, we're going to need 0.0097 of the other. So that's the way it works. So we know the relationship as well between grams and moles. We use the periodic table, atomic mass units, to figure out what would be the weight in grams of a mole of a particular molecule or atom. In this case, aluminum is a single atom, right? It's just aluminum. So we look on the periodic table and we find aluminum, okay? We find that aluminum has an atomic mass unit weight of 27.0, okay? That tells us that 1 mole of aluminum is equal to 27.0 grams of aluminum, okay? We're also told that we have 1.2 kilograms of aluminum. We're going to multiply this by the correct conversion unit. That's going to be 1,000 grams per 1 kilogram to give us 1,200 grams of aluminum that we have in our thing. Now we're going to look at this to figure out how many moles is that. So we're going to multiply 1,200 by the correct conversion factor. We can either say 27.0 grams per mole, or 1 mole times per 27.0 grams, right? 1 mole or okay, the one we want is the one that's going to get rid of grams and leave us with moles. So it's going to be this one. So 1 mole per 27.0 grams. Grams cancel, we'll end up with moles. So I'm going to divide 1,200 by 27. So that goes in there, not quite 5, it's going to go 4. So it's going to be 44.444 repeating. So that tells me that I have 44.4 moles of aluminum in this reaction when I have 1.2 kilograms. That's the same as 44.4 moles. Okay, they're equal. This is equal to that. It's the same thing. Okay, so I'm going to use this information to figure out how many liters of solution of NaOH I'm going to need. Okay, so the molarity of the NaOH, that means the number of moles per the number of liters. I know how many moles I have. I have 44.4 moles. I know the molarity is 6.5 molarity. What I need to figure out is the number of liters. Before I put in my numbers, I'm going to use algebra to set up my liters. So I'm going to first multiply both sides by number of liters. And I divide both sides by molarity. So I have liters. The number of liters equal the number of moles divided by the molarity. So that's going to be 44. Oh, wait a minute. Here I have 3 significant digits. Here I have 2. This should actually be only 2 significant digits. So 44 moles divided by 6.5 molarity. Using my calculator, I want, by the way, 2 significant digits. So I get 6.7692. So I'm going to say 6.8. 6.8. And this is the number of liters, right? 6.8 liters. So let's look back at the problem. I need to answer how many liters of this solution are needed. The answer is 6.8 liters of this solution are needed in order to make sure that all of the aluminum has reacted. All of the 1.2 kilograms of aluminum have reacted. Okay? If you have any problems or questions about this, I hope you contact me, and good luck.